Hello. We defined the median as a measure, another measure of central location. So it's an alternative to the mean and very intuitive and simple measure, like started from a very simple idea. And it is usually different from the mean. So in our data, the mean was 6.05 million. But if you, as I said, Kentucky is the median, so it's 4.34, which is smaller than the mean. So as you can see here, the median and the mean are quite different. Like, so they differ about like 1.7 million, which is huge. So nearly 25% of the mean is the difference. So they are very different in general, and so now what we are going to do here is I'm going to show you how to calculate the median. And remember, we learned how to calculate the mean, and there were two different types of information we usually use. So one was when you have raw data, and the other was when you have a frequency distribution table or a probability distribution table. So depending on what kind of information you have to use different methods. Same same thing, same applies here. So how you calculate the median depends on what type of information you get. So first, let's think about raw data. You have raw data. In this case, for simplicity, I'll take just 5 Pacific states. So, and suppose that there are only 5 states in the 5 state data: Alaska, California, Hawaii, Oregon, and Washington. So the 5 states are given, and you would like to calculate their median. And of course, these are population. And what we do here is rearrange the states, the data in the ascending or descending order. It doesn't matter. So the point here is we would like to find the third one because that's the middle one. So there are 5 observations. The median is then automatically the third largest, third smallest outcome. That is 3.83 in this example. To find it, you have to order them in some order, in an order. Or you may just put it like this: smallest, second smallest, third smallest. So this is the median. Or largest, second largest, third largest. This is the median, right? The median is therefore 3.8, 3 million. What's interesting here is if you calculate the mean of these 5 numbers, the mean is nearly 10, 10 million. It's nearly like more than twice, more than double of the median. So, as I said, the mean and the median can be very different, and usually they are different. So, they are different. So this this is when you have an odd number of observations. When you have an odd number of observations, you can just choose one observation exactly in the middle of the data. However, when you have even number of observations like this, now think about New England states: Vermont, Rhode Island, New Hampshire, Maine, Connecticut, Massachusetts. So there are 6 states, and I already ordered them. They are in the ascending order. And in this case, the middle is the the number between third and fourth one. So third, you have to cut here in the middle of in between the third and the fourth. So to choose the point, what we do is just simply take the average of these two guys. Take the middle point of middle value in between these two, right? So take two middle values and take average of them, right? That's how you calculate the median. So the answer is 1.325. 1.325 is exactly in the middle of these two values. So that's the median of New England states. Um, and also the mean is different, 2.4. So as you see, this is how we calculate the median, and the idea is pretty simple. Just choose the middle one. Just and if there are 100 observations, you have to find what is the 50th and 51st smallest or largest observations and find their middle value. That's how we find the median. And what's more complicated is when you have a probability distribution table. When you have probability distribution table, it's the definition of the median becomes a little more tricky mathematically. I will explain why. So ideally, we would like to have this. If there is a median, the median of x must satisfy these two equations. So probability that an outcome on the smaller side is 50% and on the larger side is also 50%. So that's the definition, our original definition of the median. So we would like to cut the distribution of x into 50 and 50. However, usually this equality does not hold. Equality does not hold because equality sign is included in both probabilities. So this equality may make the probability greater than 50%. So mathematically, we have to modify this condition into inequalities. So it's a little bit tricky, but I will show you why this has to be like this in an example later. So now, probability on the smaller side of the median and the larger side of the median, each of them must be greater than 50%. Then that's the median. So mathematically, there is only one median value satisfying this both inequalities. So I will show you why both have to be greater than 50%. So here is another example to work on this. So think about number of pets a family raises. So number of pets distribution is like this. Say 0, 1, 2, 3, 4 per household. And there are 28% of households with no pet, and 21% of households have one, and 19% have two, and blah blah blah. Let's find the median. And of course, there are 5 different outcomes, but 2 is not the median. Even if this is the third smallest, but we have to consider the probabilities. So we are not just dividing the 5 outcomes into half and half, but we are dividing the probability. So probability is the point rather than the number of outcomes. Okay, to think about this, we have to introduce another new concept. So what we are going to do here is we are going to find a point. Up to that point, the probability should be greater than 50%. And after the point, the probability is also greater than 50%. So we would like to calculate the probability up to a point. That's what we have to calculate, and we call that kind of probability as the cumulative distribution function, simply CDF. So it's cumulative because we are considering cumulative probability up to a certain point, from 0 up to a certain point. So it's cumulative and distribution function. So for example, this is a cumulative probability. Probability x is smaller than or equal to 3. So probability up to 3. 3 or smaller, right? So then from the original probability distribution table, CDF is calculated like this. First, cumulative probability at 0 is simply 28% because there is nothing to accumulate. It's the smallest outcome. And then next, cumulative probability at 1 is the probability that adds all the probabilities up to 1. So 0 and 1. Probabilities for 0 and 1 are added to make the cumulative probability. Similarly, 2 at 2, the cumulative probability is 68%, and 3, 4. At 4, if you accumulate probability up to 4, it's everything because all the probabilities, all the possible outcomes are 4 or smaller. So in the end, the cumulative probability should be 100% at some point at the largest possible outcome, right? It's obvious. So always it should be increasing, right? As you increase the point, it accumulates more probability, so at least equal or larger. And by the way, we are calculating the median. Remember, this is what we have to do. So remember, this is the first one is the cumulative probability. Cumulative probability up to the median, right? Probability smaller than or equal to median is the cumulative probability. Cumulative probability should be greater than 50%. So 0 and 1 cannot be the median. They do not satisfy the first inequality. And there are 3 guys, but among the 3 guys, the smallest one is the median. You do not need, if you want, you may check this inequality by yourself. You may calculate probability for 2 or 3 or 4. That should be greater than 50%. But without calculating that, you can simply take the smallest value with cumulative probability greater than or equal to 50%. Then that is 2. This is an error, right? Small. So right. So this inequality is satisfied by these 3 numbers, and among them, we take the smallest one, right? Smallest one. And if you calculate the probabilities on each side of the median, on the smaller side, there are 68%. On the larger side, there are 51%. The reason why they sum greater than 100% is because 2, the probability at 2 is 19%. So 19% is included in the smaller side and the larger side at the same time. Because of that, we have to make both inequality greater than 50%, right? So the equality is included here. 2 is included in both cases. So the probability of 2 contributes to both, so they both have to be greater than 50%. So remember, it is not the nearest value. It has to be greater than or equal to 50%, right? So even if 49% looks more likely to be the center, it's not. It's not. So 1 is not the median. So the median must have cumulative probability greater than 50%. That's what you can see here. And similar question, the same question for your exercise. So household family size is either 1, 2, 3, 4, 5 plus. And find in this distribution table, find the median household size. In this case, what you have to do here is you need to calculate the cumulative, make another line in the table, and calculate the cumulative probabilities for each cell. That's how you calculate the median. Okay, I'm going to stop here and answer this question, and then I will give you the answer in the next one, in the next video. See you there.